So for this one, we've got to send Claude down small enough that he can swim around inside the beaker and get underneath that weight and see all those different forces interacting. So I'm thinking probably down to about 1/20th size. So we're gonna have to stick him inside of here and set the meters. So we're gonna have to dial in the modulator and adjust the angulator so it's just right. And there he goes. The rock hanging on the string has a mass of 200 grams, so gravity's pulling down on it with a force of about 1.96 newtons. As the rock is suspended in the water, there's a small amount of force from the water pushing down on the top and a larger force of the water pressure pushing up on the rock. The net force is what we call the buoyant force.
Buoyant.
The rock is also pushing away or displacing the water. This rock has a volume of 25.4 milliliters, so Archimedes' principle says that the buoyant force is equal to the volume displaced. That means the buoyant force would be about 0.25 newtons. So the rock is really only putting 1.71 newtons of force on the string. Now, buoyancy has some real-life applications that we take advantage of every day, like... So we can't see this because these things are so tiny that we couldn't even see them with a microscope, even the highest power microscope. So let's do something really fun. Let's send Claude in to investigate what happens when we drop a sugar cube into the water and those sugar molecules start to dissolve. Let's send him into the Claude compressor.
Yes, I think we have to.
All right, so we're going to put Claude in. Now this is gonna be rough, Claude. We're gonna have to send you down really tiny.
You got it, buddy.
I'm thinking like 25 angstroms. This is gonna be super tiny. Crank that one down all the way, and I think we're good to go. A sugar cube is a gigantic matrix of trillions and trillions of sugar molecules. And sucrose, or table sugar, is a disaccharide molecule. That means it's made of two molecules hooked together, one glucose and one fructose. Water is a polar molecule with a positive and a negative charge. The sucrose molecules on the surface of the sugar cube move into the spaces between the molecules, and then the glucose and fructose molecules get separated as the positive and negative charges on the water molecules pull them apart and attach to the charged region on the sugars. These tiny molecules keep filling in the spaces between the water molecules until the sugar cube is totally dissolved and we can't see them anymore because they're so small. Now we have the solution of sugar water. But not everything dissolves in water. This sugar cube dissolves in water, and salt will dissolve in water. So we're gonna send Claude in on the job through the Claude compressor and let him check out the waves. So Claude, into the Claude compressor, and we don't need to make him very small because the waves that are sound waves are actually pretty long. So we're only going to turn him down to about half size, okay? And attenuate that just a little bit, and then we're ready to go.
There you go, bud.
Have fun, Claude. Since the speed of sound in air is constant, if the frequency goes up, the wavelength has to go down. We will assume the sound is traveling at 343 meters per second if the air is about 20 degrees Celsius at room temperature. Let's start with the low note on a tuba at 110 hertz. The distance between the crests on the wave would be 3.12 meters. Now, let's listen to a note on a clarinet at 440 hertz. Its wavelength is shorter at 0.78 meters. To get even higher, Claude's gonna play a flute for us at 880 hertz. That wavelength measured in at 0.39 meters. So we can clearly see that the higher the frequency, the shorter the wavelength. We have lots of tools that can help us visualize sound. One of them I have here on the table. This is a little... So we're gonna send Claude into the Claude compressor, and we're gonna show you what this would have looked like and how the flood helps us make sense of footprints in the lower strata and then the actual organism being found in the higher strata. All right, Claude, we're gonna launch you into the compressor. Set the attenuator down, and the transmogrifiers got to be adjusted just right. And I think he's off. The evolutionists believe that animal tracks in Grand Canyon are found millions of years earlier than the fossils of the animals themselves. But when we put on our biblical worldview glasses, there's a better explanation. As the rain came down and the floodwaters rose, massive amounts of sediment were moving in the water in slurries. Tidal forces and shifting currents would deposit layers and critters would get stuck in the sediments. They would have to crawl up as each layer was deposited, leaving their tracks behind to be buried quickly. But then the next layer would come, and man, would they start to get tired from all of that climbing. Eventually, they would be exhausted and find their final resting place. Their bodies would eventually be fossilized in that higher layer. But their footprints in the lower layers were not laid down millions of years before, but just hours or days earlier. Starting with God's word rather than man's word helps us make sense of the world we see around us.
Grandpa?
Now, there's an interesting feature in the Colorado Plateau, that area just north of where you can see how it flows and moves like that. So little creatures like Claude would have been swimming around, crawling around, and they would have got trapped and buried down inside of those sediment layers. Oh no, I'm trapped, I can't get out. And we'll see what happens to him in this fossilization process. As a creature is buried in sediments, it has to be buried quickly, and more layers have to be deposited on top, or scavengers and bacteria would decompose it quickly. The flood of Noah's day gives the perfect conditions to explain how this would happen. As the animal died, its body would have been trapped in the fine particles of mud and sand. As it gradually decomposed, the layers that contain lots of minerals and water were a perfect environment to start transforming the flesh and bones or shells into stone, one molecule at a time. Many people believe this would take long ages to accomplish, but with the mineral-rich waters in the flood sediments, fossils could have formed rapidly in weeks or months, not millions of years. All right, so Claude has been fossilized. He's entombed in this limestone grave here, and we're gonna be able to extract him. Now, have you ever been on a fossil dig and been able? All right, we've got the Claude compressor ready. We're gonna send Claude in. We're probably gonna go down about 1/20th size, and we're gonna send him into that checkerboard, and we're going to have him stretch those squares together so that we can see if those colors are any different, because you said you thought number 2 looked a lot darker. Claude's gonna help us figure it out. Okay?
Oh, I see, even he's wearing a bow tie today.
It looks like he is. I wonder if that'll make it into the animation with him as well.
We'll see.
Let's find out. Okay, we're gonna put Claude into here, and we'll put him in there, turn the actuator down, and the attenuation to 1/20th, and there he goes. Our brain is constantly comparing things to make sense of the world around us. Square 1 appears to be a lighter shade of gray than square 2. Let's have Claude help us compare the two without all the distractions. All right, Claude, go grab square 1 and stretch it down. Now grab square 2 and stretch it across. Now what do you see? They are both clearly the same shade of gray. There's a spiritual truth we can learn from this physical example. We need to remove all of the distractions around us as we look to God's word to see what is actually true about the claims people are making. Another way that we use color in entertainment situations is with 3D glasses. So this type of glass. Now, if we're gonna get Claude to take a ride on one of these little tiny seeds, we're gonna have to shrink him down pretty small. So let's go ahead and send him into the compressor. All right, Claude, here you go. And we'll set the attenuator and adjust the polarity. All right, we'll see you in a little bit, Claude. Milkweed seeds have tiny fibers that catch the wind to help them spread. They look like tiny inside-out umbrellas. When a gust of wind comes along, it can lift them high up into the sky. Whoa, hang on, Claude. They can travel many miles through the air and land in interesting places to sprout a new plant, starting the cycle all over again. Many plants follow the growth pattern that they'll sprout up in the spring, grow during the summer, and then they kind of dry out. All right, we want Claude to be pocket-sized so we can take him out into the field with us and explore the Osage trees. So let's send him into the Claude compressor and set him for about 1 inch. So set the attenuator down, and the transmogrifier got adjusted to the right size. And there he goes. All right, let's see if it worked. And there he is. We've got Mini Claude ready to go. Gonna slip him in my pocket, and let's go check out these Osage trees. So let's head to the field.
Is Claude coming?
Oh, yeah, we better take Claude with us. But if we want Claude to fly on that rocket, he's too big to strap to the outside. Yeah. So we're gonna have to get him on the inside. That means we're gonna have to put him in the Claude compressor. So we're ready to shrink Claude down to size so we can take a ride in the rocket. So Rob, you're an engineer. You're fascinated by these things. This is my Claude compressor, and it lets me shrink Claude down to whatever size I want to so he can help us explore all the amazing parts of God's creation.
Did you make sure you included the axiomatic flux compressionator?
Oh, I had to have one of those because I couldn't have made all of these things work together. It was really hard to source, but I was finally able to get one, and it's gonna work like a charm.
I'm just checking.
All right, so let's send him down. We're gonna go, again, we need about 1/20th size to be able to fit him inside of the rocket. So I'm gonna turn on the transmogrifier and the attenuator down to 1/20th size, and he is set to go. All right, let's see if it worked.
All right.
There he is, Mini Claude, ready to go. I'm sure he'll fit inside the rocket, and we'll be able to take him for a ride. Astronaut Claude, ready for launch.
He's ready.
So we're gonna have to reverse the polarity?
Absolutely. So I'm gonna take the attenuation backward, reverse the polarity, and invert the transmogrifier, and I think it's gonna work. So let's pop Claude in here. I'm gonna set it for about the size of a medium-sized dog, and we'll see what we can do. All right, I've got the attenuation set appropriately, and it's reversed, and here we go. Claude's on the trail looking for signs of critters. Looks like he found a moose track. That's a lot bigger than those deer tracks we found. Oh, now he found some bear scat. That bear has been eating lots of blueberries. Looks like he found some hair snagged in those plants, and it's right by a pile of coyote scat, so it must be coyote fur. Now he's found a bed where a deer has laid down for a nap. And there's a little pile of pine cone scales where a squirrel has been having a snack. Looks like he smells something really strong. Oh no, it's a skunk. Watch out, Claude. Claude is gonna need a bath after that.
So Claude got to go out in the field and look for tracks and all of these things. I think we